Okay, last talk for today, and one I've been looking forward all day. Ismael Mejia will talk about Nexmark, a benchmarking suite for data-intensive systems built with Apache Beam.
Okay. Hi, I'm Ismael. I'm a software engineer at Talent, and I'm a contributor to Apache Beam. I am a member of the PMC and a committer in the community. I am the top non-Google guy in this project, contributor. At least GitHub says that. That doesn't mean that I'm the best. That means that I refactor a lot of crap and I do a lot of small commits, maybe. So this is the way it is. I work for Talent, that is a software company that makes data integration projects and all around big data, real-time system, and all this stuff. We have an open source solution, so this is worth the mention here. And more important, we are building this new family of products, and we are actively recruiting. And we are based in France, and most of people here can speak French. So if someone is interested, you can join us. I work in a team that their main responsibility is to work with Apache projects. So if you are really into open source, you are super welcome. We have an open place now, and we will have a second one in the next months. So we are going to talk about benchmarking and benchmarking big data. We are going to talk a little bit about Apache Beam and Nexmark, that is a benchmarking suite on top of continuous systems. And we are going to look a little bit at the implementation we did for Nexmark on Apache Beam and how this is done and what you can do with it. And we are going to discuss the current status of the project and some future work. So what's the current, why do we do benchmarking? This kind of seems silly, but we always have to remind this. We do benchmarking because we want to measure the performance of things, but we also want to evaluate the correctness of the things we are measuring. And every benchmark suite has these 4 basic steps, that is just generating some data. Then we aggregate and compute this data, and then we produce 2 kind of outputs, the measure of how these things are executing, and the correct results of the calculations. And we have different families of benchmarks. We have micro benchmarks, that is when we execute a really punctual function, like a sort, for example. We have functional benchmarks when we are evaluating this kind of functional requirement thing. We have more this kind of business case benchmarks, and this reminds me of, for those of you who know a little bit of the database world, all these TPC suites, that for example is a CRM system, and with the CRM system we create all these kind of tricky queries to see how things behave. And finally, we have this data mining or machine learning kind of benchmarks when we execute a really complex algorithm of machine learning, and we measure how this behaves in our cluster. So what's the problem today with the benchmarks in the big data world? The problem is that, well, we have many pseudo standards. We have this TeraSort thing that is a benchmark on sorting random numbers. We have the TPCX family of benchmarks, but we're going to discuss a little bit those afterwards. But in the end, the real problem is that we don't have a common model to create these benchmarks, because every system implements things differently. Like Spark has one way to write code, Flink has a really different way, classical Hadoop is different too. And also the existing benchmarks are really focused into Hadoop infrastructure. And today, well, not all these systems work with Hadoop. There are now many things running on Mesos and starting to get things also running in Kubernetes, so they are not also that appropriate anymore. Some mix this measuring storage-related things or more data store-related things with the real processing of data. And more important for the sake of this presentation is that there are really few things into the streaming world and into the streaming semantics of benchmarking. So the state of the art, as I said, we have TeraSort, this is just sorting some random data. We have TPCX that is a little bit more like a to evaluate Hadoop distributions. This is basically its use. We have the TPCDS suite in Spark that is really complete, but it works only on Spark. And we have others like the Intel ones, that High Bench or Big Bench, that cover many cases. They have functional benchmark, they have a little bit of streaming also. And finally, the Yahoo streaming benchmark was published 2 years ago, and it really moved the streaming community with back and forth between different systems, parsing, etc., to be better in this benchmark. But Nexmark, that's the benchmark I'm going to discuss today, was a publication done in the 2000s. Beginning of the 2000s was an exciting time for research on streaming systems. And these guys created this paper that was never published. It was just abandoned in some academic site. And they proposed a really simple but nice example of system when we are creating an online auction system. So we have people who arrive and want to sell things. They are selling things. So there are the people who then create auctions, and there are the people who want to bid on these auctions, and at the end they want to buy something. This is nice because it's really easy to explain as a business case, and it's really rich in the sense that we can express a lot of queries, let's say, around this. So things like what is the average time that it takes for an auction to complete, or stuff like that. So it's kind of nice. The original paper had 8 queries in this SQL language. That's like an SQL, but with continuous semantics, like streaming, kind of. And the Google guys took this paper, and one Google guy, Mark Shields, implemented this in top of Dataflow. And they used this a little bit to evaluate how Dataflow performed. So, well, would you think, well, what is the link between Dataflow and this? Well, as some of you may know, Google Dataflow is, the Dataflow paper is the logical basis of all on Beam, and the Google Dataflow, Cloud Dataflow, is the system of Google to execute Beam pipelines. So what is exciting for me about Beam is that there were like 2 big lines of work in the big data world. All these things that were happening at Google that nobody knew outside, only knew about because of the publications they did. And the Apache work, when they were implementing some of these ideas, like Hadoop or HBase, there was like 2 parallel lines of evolution. And of course, in the Apache world, there were really nice ideas, things like Spark that really changed the way we did things. And in the end, Apache Beam is a little bit like Google finally coming to open source a little bit and putting it all together, so it's kind of nice. So what is Beam? Beam is a unified programming model. So let's say that this is like unified SDK or API, where the idea is to have one only way to express both batch programs and streaming programs, and with the advantage of being able to be portable. So we can execute this in different systems, not only in Google Dataflow, but also in Spark or in Flink. So we have things to translate this. And this is quickly the vision of Beam. Every Beam pipeline answers these 4 questions. I will go quickly into this because it's a little bit outside of the benchmark part. But more important is that we have these SDKs today in Java and Python, and there's ongoing work for the Go one. We have some libraries on top of this. We have Chioc is a Scala library on top of this. We have an SQL that is starting now. And we have runners that are the systems where we execute this. Well, of course, we have connectors to different data stores, Kafka and all of these Hadoop things. These are the IOs. But for me, the more interesting part is the runners. So today we have all those systems that are supported or partially supported by Beam. Those who are in this small square are the new ones who are coming. The others are mostly on master or in private, those who are private. Just one thing is that Beam offers a direct runner that is a local one. It's not distributed. It's just so you can write your pipelines in your computer and test that they are valid. And this enforces a lot of things. This auto-serializes thing just to check that everything is serializable and all this stuff. So where are we today on Beam? Well, we have a quite vibrant community, at least from the Apache standards point of view. We have the first stable release in April of the last year, and currently we are in the vote for the release 2.3 this week. And I'm glad to say that Nexmark broke the vote this week, so I'm kind of proud of this, because we found a regression with Nexmark. And there are some exciting features that are coming on Beam. Is the FN API that is the ability to have multiple language now, really. So in the sense that you write your Python program and you want to execute it in a Flink cluster through Beam, and you can do this. We are working on schema-aware collections. That means that we can have more, let's say, like easier APIs, like those of Spark, for example. Well, we are also building new libraries for different subjects, so this is an invitation also to come and join Beam, and it's a perfect time because there are still a lot of things to be built. Okay, so before I said that Beam answers 4 questions, and these 4 questions are just to unify this batch and streaming semantics. And what is the problem we have? The problem we have is that normally we have events that happen in time, and this horizontal axis X correspond to event time. So the moment when an event happened, for example, I'm using my telephone, I did click, this is the moment when I did click. And this vertical axis is the moment when this event arrives to my server, where I'm processing. So ideally, we should be processing the events at the same time they happen. This is this diagonal line that we have. But this is not true. So this diagonal line, we call this the watermark. And it indicates a little bit like we don't have delayed events, but this is an approximation. We will see this in detail afterwards. But well, what are we answering here? We're trying to sum all these numbers, so they are arriving continuously because we are streaming, but we don't know when we are going to end this, when we decide to calculate. So this is what these questions answer. So what are we doing? We're just summing. So first part is okay, but when are we summing this stuff? We can say, okay, I want to know the results every 2 minutes. So we are going to group all these events that are arriving on time into windows of 2 minutes, and we are going to sum this. So in the end, we will end up with a graph like this. So we have still the events arriving in time. We have the separation on event time. But we have not still said when we are going to compute. And we do this with the concept of watermark. That is the line that I said that more or less indicates me, is this green line, that no more events are arriving. So when I complete one window and there are no more events, I materialize the sum. Then it becomes yellow in the graph. But as you see, there is the case when some event can arrive late. This is this one. And we have to get a little bit of tools to reattract these events in time. And this is what Beam offers, a set of ways to transform, we call this, to express this kind of scenarios. Like we can say, okay, if I have laid that data until this time, I can retake it and add it to this window. But well, I went too far into these details of the Beam model, but I suppose that some of you don't know all this stuff, so I just wanted to bring up some of this. Basically, a program in Beam is just a collection of steps. When you take an input and you do all these transformations, windowing and stuff, and you go to an output. We have these families of processing elements. Element-wise transformations are like map in the MapReduce model. Grouping transformation are like this shuffling and reducing in MapReduce. And we have windowing and triggers, and this allows us to play with all this time transformation and trigger where we want to trigger the compute, the aggregations. So this is more or less, in a nutshell, the Beam model. So Nexmark on Apache Beam, the story quite quickly is that Google contributed this in version 0.2, and then it was like abandoned. The guy quit Google. So the project was a little bit in the limbo, and me and another colleague, we took this and we started to refactor and to bring it back with all the changes in the API. And especially we make it generic to execute in every runner. Well, it was supposed to be like this, but it was still a little bit tight with the Google stuff. And we evolved some of the queries, and finally we got it merged in December of last year. So now it's part of master in Beam. And well, the advantage of using Beam for benchmarking is that we cover some of these issues that we discussed before. We have a rich model in the semantic sense. We have one code that will allow us to execute in every system. And also we can benefit of all the metrics that Beam has included, the API for metrics. So we're going to discuss quickly the implementation. We have just four big boxes. We have a launcher that executes one configuration of the benchmark. We have a generator that is going to create these events in the system. So these events is like new people, new bits, new auctions. And we have metrics that calculate everything, and we have the configuration of the benchmark. This is an example of some of the queries that we have in the system. There are now 13 queries. In the original paper, there were 8. But the Google guys had 5 more, so we have 13. And this covers some of these areas of Beam. Well, I won't go that deep into the detail because you have to see more in detail some of the Beam concepts. But just to explain a little bit, every query has this structure. It's a collection of events that happen in the system. We filter the events that we care about. For example, we're caring just about auctions. We filter the auctions, and then we do the transforms in Beam. And finally, we apply this result, an output to this. So, for example, we discussed a little bit of windowing before, of this thing of grouping every n minutes. Well, now there are different, more advanced ways of windowing, and this queries cover this. One thing that I forgot to say in the last slide, in this one, is that some of these questions can be answered with an easier way, but we chose a especially convoluted way to have to test more, to cover more of the Beam model, in some cases, not in all, but in some. Also, we cover things like triggering for amount of data, not triggering only in the time dimension. For example, if in some cases you can say, oh, when I have 20 samples of something, I think I can have an approximate result. So these kind of things are covered here. And we also cover the case of data that is out of order. So what happens if one bit arrives before an auction? So we store this until we receive the auction, and then we can compute, because otherwise we couldn't. So this also we evaluate with some of the queries. So, well, conclusion is that we cover most of the Beam API, that we have a pseudo-realistic example, and that we run this in every system. Well, not in all that we have, but we have covered some of them, as we will see. We use Beam on Nexmark on Beam mostly as an integration test, and what we're trying to achieve here is not a comparison of which system is better than other. It's most like that between releases we have we don't have serious regression in every runner, and so we're going to see a little bit of how do we use Nexmark, and then the warning slide. Comparing system is a really tricky thing. I mean, because first, the implementation of the runners on Beam have different levels of support. I mean, some are way more advanced than the others. Also, these native systems like Spark, Flink, Dataflow, they have different characteristics. They were conceived with a different design philosophy. So they are naturally better in some kind of scenarios. So it's not so easy to compare one to the other. Also, and this is one I especially like, all of those systems have a lot of knobs, and if you have done some Spark and Hadoop programming, you know how hell this can be. I mean, you can just change one variable in Hadoop and everything is different. And finally, well, we are benchmarking in distributed systems, so we can count with the bad luck that one machine breaks and the result is not going to be easily comparable with the other. Or if you are in the cloud, you have a noisy neighbor who is changing the way you are executing. So it's not so easy. In particular, there's a really interesting blog post from like 3 weeks ago from the Flink guys and from Data Artisans, really recommended, where they discuss a little bit also this. But well, back to Nexmark, what is cool is that if you are going to execute the benchmark suite, you just have to change the runner. So here you're executing with Spark, here with Flink, and that's it. If you want to change the mode, how we are generating the data, which means that it's batch or streaming, you just change the switch. And if you want to apply this into your local machine or into a cluster, you just change this. And this is real code. I mean, I'm not bullshitting here. And also, if you want to use the tools you use in your system, for example, in Flink, you just run Flink run and you send the jar and the job executes. I just want to remember that this is a synthetic benchmark, so we are generating the data. It's not stored in some data store, at least for the moment. You can configure the benchmark with many different parameters, like amounts of data generated, but also ratios, like how many bits on average you want for action or stuff like that. And also, we can generate artificial CPU and disk load. So for those of you who also want to test that in your clusters. This is the example, for example, this is an example of the output of an execution, just in a local execution, where I get the time that every query took, the result that it takes, and the throughput. Nothing special here. But more interesting is to see a comparison. For example, this is in blue is the Flink runner. This bigger is better, and small is the direct runner. And you can see a really huge disproportion here. But it makes sense because, as I said before, the direct runner serializes everything just to enforce serialization. So we have a way to configure the direct runner, and this connects with all these knobs things. If I disable all the serialization parts on the direct runner, what I have is this. And this is more similar. I mean, of course, there are some differences, but this is one case, for example. This is another example where we compare two versions of the Spark engine. We took 160 versus 163 just to see if we had regressions, same code in the Beam part. And you can see that for some queries we had some differences. So again, they are quite similar. Like we can say on something really, really different. So what is the current status of the project and what is the future work? We have this support matrix in every runner and every query. Those are the number of the JIRAs that are still pending, so we can have full compatibility. There are new runners who are already on Beam, but we have not executed them yet, not added to the matrix. We follow most of the Nexmark things in one JIRA, that is the 160 JIRA of Beam. So if you feel interested, you can take a look here. And what's next? The ongoing work is that, well, we want to fix all the pending things, add all these runners that are not yet there. We want really to automatize this into our CI infrastructure. So if you are an expert in Jenkins, Kubernetes, we are super welcome, because I don't want to do that, because it's interesting also to do this. And also, we have a guy from Google who is working in support for the streaming SQL into Nexmark. So all these queries that are done today with Java, the ones that we can easily translate into SQL, they will be in SQL now. And one thing that I really want to do is to extract the generator. This is a really thing that I want to do quickly. Extract the generator so it can be used for other systems. For example, if someone wants to implement Nexmark in pure Flink, that it can just take this jar and do it. And finally, there is also somebody working in a Python implementation of this, because this is part of the portability effort that we have from Beam. Well, of course, you are welcome to contribute. As I said, there are many areas when this can be improved, or in general, in Beam. I want to say greetings to all the people involved in this. Usually during this presentation you see somebody like talking and say, oh, this guy made a lot of stuff, and no. I have to be honest, the open source is like this. We have many people who make a little bit and make these things happen. So finally, I left some references for you who want to go deeper into the subject, and well, that's it. Thank you. Questions, maybe? Yes.
Thank you for the talk. I was just wondering, in the comparison, Flink versus Direct Runner, how many, is this like single node performance?
Yes, yes. This is single node performance because the Direct Runner is only local, so yes.
Okay. Yeah. Thanks.
As I said before, we don't want to get, Beam is like the Switzerland of the big data projects. I cannot get into enemies with the Spark guys or the Flink guys. I don't want to play that game. Yeah.
Other questions?
Thanks for the talk. So in the compatibility matrix,
yes.
Most of the pending problems were with Spark?
No, not really. The thing is that, we have a compatibility matrix in the Beam website, right, where we cover all of different functionalities of the Beam model. But for the case of Nexmark, for example, there are some tricky things, because you mentioned Spark. We don't have currently site inputs for Spark in streaming mode, because it's quite tricky to implement, so we don't have it yet. But it's not only for Spark. I don't know where was the matrix. Yeah, here. For example, well, you see that the one who has more is Spark, but it's not exclusively because, for example, the model of Spark is different. It's not pure streaming. It's not something like that. It's the level of implementation that makes the difference. And you can remark that it's not Google Dataflow is not there because we were really focusing to the open source stuff. I hope the Google guys do this one day, but not my job.
So you do expect that both for the benchmark and the rest of the Dataflow model, there will be a convergence, and most of these problems will be ironed out?
Yes, of course. We are behind this. Actually, one interesting output of this work is that we are right to solve like 10 JIRAs in the different runners. I was annoying the runner authors about these things. For example, Alyosha from the Flink guys, I was all the time, Alyosha, I want this because I want this. But problem is the Spark guys, some of them quit the project, and now I'm also part of the guys supporting this, so I will have to fix this also. The others.
Thank you.
Any more questions? No? Okay. Thanks again.
Okay, thank you.
Thank you everyone for spending your day here or part of your day here.